Good morning. Welcome to the Converting Sugars to Ethanol video tutorial. This video will outline materials required and procedures to be followed when converting sugars to ethanol. First, let's start with some background. The fermentation process has been around for thousands of years to preserve grains. Fermentation is a microbial process in which its cellular metabolism converts monosugars, such as glucose, into an alcohol or an acid as its main product. Glucose undergoes multiple reactions of oxidation called glycolysis, and the final product is pyruvate. The pyruvate is then converted into the final fermentation product of alcohol or acid. Ethanol is one of the most predominant liquid biofuels produced via biological conversion of renewable biomass. It involves yeast and, to a certain extent, bacteria to produce ethanol from pyruvate. For every 1 mole of glucose, 2 moles of ethanol and 2 moles of carbon dioxide are produced. In this lab, you'll investigate the fermentation process for converting cellulosic biomass into ethanol, finishing what was started in the pre-treatment/saccharification lab. Next, let's move on to the setup of the lab. First, label the Falcon tubes with your team initials, date, and sample description. Use the samples created from the pre-treatment lab, placing approximately 10 milliliters of each sample into the corresponding labeled 50 milliliter Falcon tubes. Create a dextrose sugar control using sugar concentrations your team would like to experiment with. Test the initial soluble carbohydrate concentration using the refractometer or Brix reading. Record this data. Weigh tubes with remaining biomass sugar solutions and record this mass. This can be used to calculate the initial sugar concentration. Set up the ethanol probe. Make sure the sensor is covered with a small piece of Teflon tape. Make sure any wrinkles are smoothed out. Connect the probe to LabQuest 2 and make sure to let the probe sit for a few minutes. To calibrate, obtain prepared ethanol solutions of 1% and 0.1%. Then, pressing the red rectangle and then calibrate, hit Calibrate Now. Allow the voltage to stabilize, then insert into the 1% solution 1 centimeter above the liquid. Do not place sensor directly into the liquid. Then, let the sensor stabilize. Afterwards, press the Keep button. Repeat these steps for the 0.1% solution. When both solutions have been measured, hit Storage tab, then save calibration to sensor. The probe should now be correctly calibrated. Place approximately 10 milliliters of yeast suspension into each Falcon tube for the standard amount. Record the time you started. Test the initial ethanol concentration using the ethanol probe. Record this data and time. Make sure the common water bath is at 37 degrees Celsius. Then place the Falcon tubes within for 2 to 3 minutes. Make sure to loosely screw on the caps to the tubes. It is important that the tubes not be airtight for fermentation. Take a first measurement using the refractometer to measure glucose and the ethanol probe to measure ethanol percentage. Record the data, then return the tubes to the warm water bath. Every 20 minutes, measure the ethanol and glucose concentrations. Add glucose and ethanol data to your table. Repeat these measurements in 20-minute increments as many times as possible to observe initial rate of fermentation. Then leave Falcon tubes to the common water bath for 48 hours of fermentation. At the end of the 48 hours, take the final glucose and ethanol measurements and record the data. Thank you for watching this instructional tutorial on converting sugars to ethanol.